In this video, we're going to talk about probability of an event, and also we talk about the three axioms of probability. We assign a probability measure, that is P of A, probability of A, to an event A. This is the value between 0 and 1. And let's look at something here. If the probability of an event A is very close to 0, this means that the event is very unlikely to happen or to occur. On the other hand, if the probability of A is very close to 1, then A is very likely to happen. So the main subject of probability theory is to develop tools and techniques to calculate probabilities of different events. And then probability theory is based on some axioms that acts as a foundation for the theory. So let us state and explain the three axioms of probability. So the first axiom, for any event A, that means that the event of A should be less than or equal to 1 or greater than or equal to 0. That is the probability for any event that is A. The probability of the event of A should be greater than or equal to 0 or less than or equal to 1. This is axiom 1. For axiom 2, it said that the probability of sample space is P of X is equal to 1. So probability of sample space is equal to 1. Let's look at axiom 3. For axiom 3, if A1, A2, and A3 are disjoint event, then we'll have our probability, that will be probability of A1 union A2 union A3 be equal to probability of A1 plus the probability of A2 plus the probability of A3, if only the events are disjoint. Let's take some few moments and make sure we understand the axioms true. So the first axiom, which state this, the first axiom state that probability cannot be negative. The smallest value of probability for P of A is 0. If P of A is 0, then the event A may be considered impossible. So if P of 0, probability of the event A is 0, is termed as the event may not be what? Possible, impossible. For practical purpose, the second axiom states that the probability of a whole sample space is equal to 1 or 100%. The reason for this is that the sample space S contains all the possible outcomes, right, for our random experiment. And the outcome of each trial always belongs to what? The sample space. So therefore, the event of the sample space occurs and its probability is 1. So with the third axiom, right, it's probably the most interesting one. The basic idea is that if some events are disjoint, what does it mean to be disjoint, right? There is no overlap between them. So in that case, with their Venn diagram, let me represent it with their Venn diagram with axiom 3. We are going to have their Venn diagram to be this. So we have their sample space to be this, and this is A and B, and they are disjoint. Then the probability of their union must be the summation of their probabilities, right?